Hello, everybody. Today I'm going to be starting a series that I will be calling Learning Calculus. And today's topic is pre-calculus concept. So it's not going to be as interesting as learning actual calculus, but it is stuff that is still important and fundamental. For a quick introduction and why I'm qualified to teach you some calculus, I recently graduated. I took BC Calculus and got a 5. And when I grow up, I hope to teach calculus or some sort of math as a teacher. And always remember, the best way to improve at calculus, or anything for that matter, is by actually practicing and doing calculus work. With that out of the way, let's go on to what we'll be learning today. Today we're going to go over the unit circle in trigonometry. We'll be going over factoring and finding roots. We'll be going over exponentials and logs, and then some graphing basics. And as a quick aside, this is not everything, but these are some of the most important stuff that I think everybody should review when they take a calculus class. So let's go over some important unit circle stuff. When you have an ordered pair x, y, it is also the same as cosine, sine. So the x is cosine, the y is sine. This is really important. Once again, you should know this stuff. This is also important. Tangent is just defined by sine of x divided by cosine of x, which is also the same as y divided by x. And then cosine squared plus sine squared is equal to 1. These are like the most important trig identities that I think you should know. I wrote a couple others, including 1 plus tangent squared equals secant squared, and then the reciprocal functions. If you move on, this is the actual unit circle that's super infamous. Luckily, in calculus, generally, degrees won't be necessary. In fact, I don't think in the entire year that I took calculus 1 and 2, I don't think I ever saw degrees once. So get used to your radians. I personally think that radians are easier anyways because there's a pattern with them. And that goes for everything on the unit circle. It is all built with pattern. As a quick example, I wrote right here, all of the x over 4 radians will have the value root 2 over 2, and then the other value will also be root 2 over 2. So let's take a look at that real quick. You have pi over 4 right here at the 45 degrees, and it's root 2 over 2, root 2 over 2. Really easy. You have 3 pi over 4 right here at the 135 degree mark, and that's just negative root 2 over 2, root 2 over 2. And that goes for all of them. The unit circle is pattern-based, so it does take some time. You have to put in some effort to learn that pattern, but I think it's much easier than memorizing every single exact value because it's easier to stick in your brain if it's less information. And then finally, the final thing that I think is important to remember about the unit circle is the acronym All Students Take Calculus, ASTC. It's an acronym and it describes which quadrant each trig function is positive. So all trig functions are positive in the first quadrant. Only sine is positive in the second quadrant. The third quadrant, tangent, is positive because tangent, once again, is defined as y over x. In the third quadrant, everything is negative. So when you divide two negative numbers, you get a positive number. So that's why tangent is positive there. And then cosine is positive in the fourth quadrant, right down here. Now let's quickly go over finding roots and factoring. These are just some quick methods. If you don't know how to do any of these methods, then I would quickly, search it up, revise yourself, do a few practice problems. The greatest common factor is really easy. It's really common, you'll see. Quadratic formula is long to write out, but you can use any 3-term polynomial and use the quadratic formula. So it's kind of like your Swiss Army knife. Factor by grouping is also really easy. It comes up sometimes. You just have to be able to recognize it. Same with difference of squares and the sum of cubes. Once again, these are all really easy. Once you do recognize them, you can knock out problems really fast, but you just have to be able to recognize them. One important thing that I will mention about the difference of squares is that you can't have a sum of squares. It has to be a difference of squares, but you can have a sum of cubes. And then factoring with the X method, I don't know if this has an official name, but this is what I mostly use when factoring or finding roots because I just think it's the easiest. You just find two numbers, A and C and B, that add to be A times C, or sorry, that multiply to be A times C, and then add to be B. As a quick aside, the point slope form is just y minus y1 is equal to m, which is your slope, multiplied by x minus x1. And all you need is a point and a slope to be able to make a line. In calculus, it's really interesting. Lines are super important, which is something that a lot of calculus students wouldn't expect because it's a line. But a line can tell you so much about change, about how things relate to each other. Lots of calculus problems will be involved with finding a line. So, quick aside. Here's information about exponentials and logarithms. So exponentials are normally written as y equals a times b to the power of x, where b is not is above 0, b is not equal to 1, and a is not equal to 0. And then logarithms are the inverse functions of exponents. And then here's the form that it's written in. It's y equals log base a of x. So its inverse is a to the power of y is equal to x. And if you don't know, I like this acronym. It's BOP, B-A-P. It stands for base, answer, power. And you can see that I've color-coded. Here's the base, here's the answer, and here's the power. And then we have exponent laws and logarithm laws. These are all really important. Once again, if you're not familiar with these, then I would be. And then a quick aside, the number e and natural logarithm. These are introduced in pre-calculus, but they are extremely important in calculus. So e is defined by, this is probably new for pre-calculus students, a limit as n approaches infinity of 1 plus 1 over n raised to the power of n. You don't need to know what that means. Basically, it occurs in nature because it represents exponential growth and decay. If you're interested, actually knowing more about E, there's some great videos out there that explain where it actually comes from. It came from a financial problem. So when a logarithm's base is E, we call it the natural log, or ln of x. So just know that whenever you see ln of x, that's a natural logarithm, so the base is E. And like I said, pre-calculus introduces these. Calculus uses them all the time, so you'll get used to seeing them, don't worry. Also, a quick aside that I didn't even write down, when the log is just written as log of x, it's generally understood that its base is 10. And that's important for more sciencey stuff. And then finally, let's end with some quick graphing information. So these are all of the parent functions that I'd recommend you know. Some ones that might be interesting to talk about. Obviously, quadratic formula, cubic formula, square root and cube roots. 1 over x is my favorite function, I think. I just think it's very fascinating how 1 over x works. You'll learn to love it in calculus. Like I said, logarithmic, exponential, and then know your trigonometric function. Sine of x, cosine of x, tangent x. I wouldn't say that the reciprocal functions are as important, but they still show up. So recognizing what they look like in your brain could help. Remember, they kind of look like U's. They're weird. Let's talk about odd functions and even functions. So odd functions are functions that look the same when rotated 180 degrees around the origin. So for example, linear functions are odd. Cubic functions are odd. Cube root functions are odd. Even functions are functions that look the same when reflected across the y-axis. So absolute value function is even. Quadratic function is even. The square root is not even. Sorry, I don't know why I was going to say that. So being able to tell if a function is odd or even is really useful when dealing with calculus problems. It's not super important, but I thought I would just mention it. And then being tell if a root or a zero will cross or bounce. This is especially important with polynomials. It deals with the degrees, so the multiplicity. Um, you know, if the multiplicity is even, then that means that the graph will bounce at that root. And if it is odd, that means the graph will crash at that x-axis, at that x value. And let's end really quickly talking about asymptotes. So asymptotes are, somewhat important in calculus. Well, they're very important because they are what we're going to be talking about next, which is limits. Vertical asymptotes are much more common and more frequent. And they happen generally when you're dividing by zero. When there's some sort of problem in the denominator that makes it impossible to divide by. I also should have written it here, but dividing by infinity would also make a vertical asymptote. Or sorry, dividing by infinity would be a horizontal asymptote. I apologize for that. Horizontal asymptotes, once again, are kind of important when dealing with limits. And I see them as a comparison between your leading terms. I wish I could have like a diagram showing this, but let's just imagine a function f of x is equal to ax to the power of n divided by bx to the power of m. So if n is greater than m, so that means that the top of the fraction is more powerful or big, you can say, than the bottom of the function, then no horizontal asymptote will occur. I like to think of it with limits. If n is super big and m is smaller, then you'll just be able to eventually divide by that number, if that makes sense. If you think about just in a general sense instead of actual numbers. If n is equal to m, a horizontal asymptote will be at y divided by b. So if these are equal, then the x's basically will cancel out and you'll just have a horizontal asymptote a over b. And then if m is less than n, the x-axis will be a horizontal asymptote. And this can kind of be seen with 1 over x. N, which is the top of the function, is bigger. So that's why there's a horizontal asymptote at the x-axis right there. So that's just some quick information about pre-calculus concepts. Like I said, there's much more, and you probably remember a lot more than I went over in this video. But calculus is cool, and I'm excited to start this series and, keep on bringing out videos. So yeah, thank you for watching. Have a good day, and keep on learning calculus, I guess.